Good evening. Good evening. I had no idea what time it was. Good evening, everybody. I think it might be evening, might be late afternoon for some of you. It is wonderful to see you here this evening. And I know we've got a few people flitting in and out of the waiting room, so we're just going to give it a second or two or three or maybe 30 to get some people settled and in. I don't want to take too long though, because Kent has some amazing things to show us tonight. In the meantime, while we're getting ready, if you want to pull up your chat, we're going to have a few links for you. And I think, Linda, if you have a moment, if you could toss that attendance, she did. Linda just tossed the attendance link into chat for the workshop tonight. You will definitely want to take a moment to click that. We are not collecting any information other than your name. And we do that so we can send you a certificate of participation. So if you could go ahead and click that for us, that would be wonderful. We will also share out the slides for tonight. And there, of course, will be a follow-up email as well, where you'll get the recording, the slides, all of Kent's sandbox links and everything, because that's the best part, is all of this work Kent went to and then just so willingly shares it with all of us. So we so appreciate that. If you're just joining us, looks like we have a couple more joining, Linda. If you want to toss that link in one more time, maybe. Yep, looks like we're in now. If you're just joining us, please take a moment to go ahead and click that attendance link. Again, that attendance link will be what allows us to send you a certificate. So go ahead and do that. Certificate should come out probably tomorrow morning is when I'll be sending that out. All right. Now, I know that Kent has some amazing, amazing things to share with us tonight. And I am very excited about his workshop. So we're going to go ahead and get started. So go ahead and let's head to that second slide, Kent. We're going to be doing a classic math puzzle meets Java programming tonight. Now, if you would like that slide deck right now, and you may want the slide deck right now, there's going to be a ton of slides in it. You can either scan that QR code if it's easier for you to watch that on another screen, or you can browse out to codehs.com/math-java-slides. That is going to have all of Kent's links. You'll have access to all of the sandbox links as well. So again, you can use that QR code, or you can click on that link. If you are just watching tonight, you will definitely have access to this after the workshop is over with, and I'll send out that follow-up. Let's go ahead and head to slide 3, Kent. All right, now I'm pretty sure I'm looking at this list and I think I recognize pretty much all of these names. So I think you've probably all got accounts. If you don't have a CodeHS account, please take a moment to head out to codehs.com/signup and create your free teacher account. If you are not familiar with CodeHS, you do not have to pay for anything to use the platform. So go ahead and take a moment to sign up. Let's go ahead and check out that next slide, I think. Yeah, let's go to slide 4, Ken. All right. So this is going to be one of the links that you are going to see this evening. This is the link for Kent's sandbox folder. And we can go ahead and toss that into chat. And this is where you'll be able to get to Ken's sandbox program that he's going to be demoing tonight and talking through tonight. Now, the really great part of this is once you get out to Kent's sandbox folder, you'll see all of his files. And Kent, if you could go ahead and go to slide 5 for me. If you've never done this before, this is the greatest part. You can actually fork or copy Ken's entire program. So you don't have to recreate the wheel. I know I like to try to recreate programs and make them my own, but I often make a lot of good typos. So if I can start with somebody else's copy and just fork a copy of their program, that is going to be a great way to actually work with that code, make changes, and save it on my end. You're not going to impact that original sandbox. This is going to be a copy for your CodeHS sandbox. If you're not sure how to fork something, go ahead and drop a message into chat, and Linda or myself can help you with that once it's going. All right. So I think I have talked enough, and you are not here to listen to me talk tonight. I want to turn this over to our coding guru, Kent Pendleton. Kent, take it away. It's all yours. Thank you.
Well, Lori, thank you very much. Linda, thank you so much for helping me out. I appreciate it. And all you guys, it's so nice to see you. I hope your school year's going well. Our objective today is to talk about something called the multiplicative digital root, and probably none of us know what that means. And so let me give an introduction, and we'll see how we can deal with that from the Java perspective. So I'm going to go to our next slide here in the slide deck. And so you might be asking, multiplicative digital root? And I'll let you read about it here. I'm going to just explain, but I will say that there's a little link down here where it says learn about MDR, and I'm using that as an abbreviation for multiplicative digital root. So you can learn about the MDR at Math World Wolfram, which it will give an explanation and some much deeper things, which are kind of fun that you can deal with. But so here's a little example that I came up with. And so I want you to imagine we're starting with a number, an easy number like 77. And we're going to go through some kind of process just because it's fun. And we're going to take every digit within the starting number, which in this case is 7 and 7. And if I multiply them, multiplicative, I get a 49. And then the question is, what happens if we keep doing this? All right. What happens if we keep multiplying the digits because we have nothing else to do in our lives? So 77 becomes 49, 49 becomes 36. And this late in the day, I'm doing good if I can multiply like that. So I'm glad I did this early. 36 times or 3 times 6 is 18. And then you see what's coming like a freight train, right? 1 times 8 is 8. And then once we get to the bottom of this process, we get down to one number, and that's called the digital root. It's the root of this process that we went through. Now, what's kind of interesting is that we didn't know ahead of time how long this was going to go on. We just knew that we would keep going until we reached a single digit. And so what we say in the math parlance is that this implies that the multiple digital root or multiplicative digital root of 77 is 8. So the end product is 8. The initial value was 77. We've got this weird process that we need to see if we can get Java to do something. And it says this event, if you talk about Math World Wolfram, it says this event is said to have a persistence of 4 because it took 4 steps to get to the 8. And when I'm talking to my students, sometimes I think, well, Mr. Pendleton, there's 5 numbers there. Can't you count? Well, I do have trouble counting, but if we think about taking steps, there are 5 numbers, but if this is the initial number, it did take 1, 2, 3, 4 steps to get there. So it depends on how you want to look at it. If we look at the chain, there are 5 numbers. If we look at the number of steps that it took us to get there, then it took 4 steps, and that's what they call persistence. Now, you could sit there and think for a moment, if I'd started with a single digit number, which would be kind of like a boundary condition, you would think, well, that process should end immediately, right? Because if there's no several numbers to multiply. So if I'd started with an 8, then the multiplicative digital root of 8 would be 8 with a persistence of what? It'd be 0 in that case, right? Because it never persisted. It just died on the vine because it was a single number. So this is what we want to digitize in Java. So now, if I thought about the big ideas of what we're talking about today, I came up with about 6 of them. And if you look in my sandbox, I listed them all out in list form, but this looks a lot glossier, a little bit nicer with some color and some amazing graphics, I must say. So step number 1, it says the driver code is supplied. Now I call driver code the stuff in the main event or the main method that kind of is an outline of things that we're going to do. And in this circumstance, I supplied this for you. And I also gave it to the students. Sometimes I give them a fully functional main event or driver code, and then they have to infer from the driver code and from the results of the driver code what we're supposed to be doing in the other part of the program, which is creating what we're calling an MDR class. And again, I abbreviated it. Multiplicative digital root is long to say. So I said, let's just make an MDR class. And so that's what we're doing. But the driver code is supplied, and we only need to modify it, as I would say, as we do kind of an incremental development. So sometimes I'll tell the students, hey, don't mess with the driver code, except comment out some stuff. Not all of it's going to work at first. Comment out what you can at first to get little bits of pieces to work, and that will build your confidence. And then by the time we're done, the whole thing will be enabled and we'll hopefully get the same output, and we'll all be happy. So the question is, how are we going to develop this multiplicative digital root class? And there's really three things that we're going to be doing kind of simultaneously. First, we're going to study the driver code. So we know enough Java that we can kind of look at this and say, well, this is doing this and this is doing that. And so we're going to examine the driver code. We trust it because our teacher gave it to us. And then it says, use the sample output as a guide to what we need in the MDR. So I give a comment block at the bottom of the driver code to show this is what you should get. So if you don't get this, you know something's wrong. And then also in developing a class. So I use this lesson. In fact, I taught this lesson maybe 6 weeks ago, 5 weeks ago, something like that. And I use this to for a couple of objectives. One thing is to remind them about what I call robust class design. And I have a little goofy sentence that they have to memorize and say like a mantra or mantra. And it's really crazy. Perhaps clown nonsense is constructive only toward getting settlers underwear, because I found that there are basically 10 things that you need to make a fully functional, robust class. And the first letter of each of these words kind of reminds me of those ideas. And I'll tell you what they are in a minute. And so you can see the lecture for details, or if this is too much, you can run screaming, but we'll see what that sentence means in a moment. And then I will just mention that I did supply the shell for MDR. And some of the methods were listed as no touch, meaning that, hey, don't mess with these. We're going to study them and you really do need to understand them, but we're focusing on some other things. And as you should see in a moment, we're focusing mostly on creating some constructors, and we're focusing on how do we write an iterative routine for finding MDR or the digital root. How do we take the iterative code and then see how we could retrofit it for recursion. So I'm using this as a way of reminding the students how to do class design, how to do some recursive stuff. We're reviewing array lists. So this has got all sorts of good review stuff in it. And so I'm telling them then we need to not mess with the no-touch code, but we need to understand it. In particular, there in blue, it says compute digital root method. It's going to be the one that's kind of got the most juicy stuff in it, as we shall see in a moment. The other big ideas is I nearly always insist that students, when they're writing classes, that they need to write a ToString method, even if I didn't ask them to. I think it's just a good practice that they need to know what is being constructed as you make an object. And so I use the ToString method as a way of saying, this is what we made. Now, hopefully it's what we wanted. And so I think it should always be part of class design. And so in the little mnemonic sentence I said earlier, that I'm sure you've memorized by now, perhaps clown nonsense is constructive only toward. Well, the only toward in our little sentence stands for overloaded. The O stands for overload, and then T stands for ToString. So if you're new to Java, you might remember that the object class provides its own ToString method, which is kind of worthless. It tells us what the memory address is of our object, but that, for practical purposes, doesn't help us very much. So we've also learned in Java that we can overload a pre-existing method. And so the O stands for overload. We're going to overload what? We're going to overload the ToString method. So as we shall see in a moment, when we look at the source code, I provided the ToString method this time. Now, sometimes I have the students write that, but we'll look at that in a moment. But I'm also going to point out something that I do a lot that I like in class design, and that is the ToString method usually is kind of like an encapsulation of this is the object's essence. But sometimes I would like to know a whole lot more about it. I want to know everything. And so while the ToString method returns a string, which is maybe just a little synopsis of information about my object, I will often create what I call a summarize method. And the summarize method, its job is to burp up everything. It kind of like tells you, this is everything I know about this object. And so I will often do that, and we'll see that in action here in just a moment too. You'll just notice here in the big ideas, we've also in talking about array lists. We'll see that in a moment too. And you might think about why that is. Let me hit the wrong place. Why do we need an array list, somebody? I mean, if you're sitting there scratching your head thinking, well, the problem is if I'm wanting to trace this event of this process, I don't know how long it's going to take. If I knew, oh, it's going to take a persistence of 5 or whatever, I could create an array to store that ahead of time and fixed size array. But when I don't know how long a process is going to be, array list is the way to go. And so that's why we needed to bring in an array list, is because cotton picking thing, we just don't know how long it's going to take. And hopefully it's not going to be a horrifying process. So that's the reason I would, and I would actually appeal to the students. And before we'd actually start talking about this, I said, what data structure are we going to need here? And so those are the kind of questions I might ask. Also, you'll notice that I provided an iterative version of the computation for the digital root. And then we're going to study the daylights out of it. But I'll often do that. Iterative means, of course, that we're going to do just a regular old loop thing, nothing fancy like recursion, but we're going to study it so that maybe the recursion makes a little bit more sense. So having said all that, let's go to the next slide here. And if I'm talking about class design, I'll often go to the students and say, you know, by this point, hopefully they know what attributes are. They're the things that an object has in its nature. So if I describe this process, I might brainstorm with the students. Of course, you see the answers here, but I might brainstorm with them and say, this is an example or an instance of a digital root process. So I use that word instance. And so I might say, what would you say 77 is? Is it important? So I said, oh yeah, that's the beginning number we're starting with. Yeah. And so that would be like an attribute, right? That is something that if I'm a digital root process, I needed to have some initiation number. So the yellow here, 77, I chose to give it an attribute of private. Of course, all attributes in Java are private on the AP. No, they don't have to be, but well, they have to be on the AP, but we can't have public attributes. We'll talk about that in a minute. But now I made them long. Now that's not part of the AP subset, but if you did a little bit of homework, you might realize that if I used integer, and we're only dealing with integer types here, integers are 32-bit, I believe. And what if somebody's really mean and they type 20 digits? We're likely to exceed the size or the capacity of an int. So I thought, let's up the ante and let's, many of my students are guilty of computer abuse and they try to type in billions of numbers to get things to crash. So we're going to go ahead and use longs this time. And I called it N0. Now I went ahead and said it's N0, kind of, I use a 0 as a starter idea. And then I said, okay, what else do we see here? Well, in orange, I see that the ultimate goal is our 8. It's the digital root. And so you'll see here in my attributes, I've got private long DR. So although it's a single digit, I didn't want to worry about having mixed data types. Well, we started with a long, but it might have gotten scrawny down to an int. I'm just saying, let's let it all be long and not worry about it. So that's the process. But I jumped all the way here to orange and I left some stuff out. Well, I would say that this thing here, I'm not just interested in the final number. I would like to know the process. And I thought of that as being a trail. And I just gave that a name, that we're blazing a trail and we would like to see the trail of numbers. So if somebody questions us and says, I don't really believe that 8 is the digital root of this, I can say, well, 77 times, or 7 times 7 is 49, and 49, 4 times 9 is 36. And so I can actually see that that evolution is correct. So since I don't know how long, we talked about, oh, it's an array list of longs, and it's a trail that we're leaving. Now, by the way, I put a little comment there. If you think about our sentence from earlier, perhaps clown nonsense is, well, I said attributes here, and I might have should have said instance variables. So attributes, I think I call them many things: instance variables, attributes, properties, field variables. There are things that my object has in its nature. And so many people like to think of these as instance variables. And so I stands for IVARs. And so in our little goofy sentence, the I stood for instance variables. But Now, here's the other interesting thing, and you're not seeing that pop up here. Somebody could say, well, what if we generate a number in the trail that's got a 0 in it? Isn't that going to make everything go nuts? If I have a 0 in there, that's going to just evaporate and go to 0 and kind of truncate the process, isn't it? And the answer is yes. So maybe we should have a Boolean in there that says, hey, let's make it optional. Let's allow you to use zeros or not, and you can choose. Oh, okay. So if I wind up with a 0 in there, if I choose to use the zeros, yes, we'll get a digital root of 0. But if I said, no, if you see a 0, omit it, don't use it, then that would be, say, should use zeros is false. And one thing I like to do is I like to use a naming procedure for Boolean with a linking verb in the front. You probably do this where if I have a linking verb like is, should, can, does, it answers a yes, no question. Should I use zeros? Yes, I will. True. So that's why I've got that should use zeros there. We've already talked about the DR in orange. Now persistence is the pink thing. And notice, if you're thinking to yourself, and I would do this with the students, okay, so we've got a trail. What would the persistence be if we know the trail? And so some intrepid student might say, well, it's kind of the length of the trail, isn't it? Yeah, but it's not exactly the length, is it? No, we would have to get the size of the array list. It's not the length, it's the size. And then maybe subtract 1 from it because we said that persistence is the number of steps that it took. So that's why, again, it's int and persistence, and we get that from the trail. That was yet another reason I got an array list. I knew I had to keep track of how many steps. And I thought, well, you know, if I'm going to have to count the steps anyway, why don't we just have a record of them? Okay, why not? So there we go. And then I've got another attribute called did use recursion. And notice the linking verb. I'm saying, all right, hey, let's give them an option. Do you want to use recursion? Yay, okay, we'll use recursion. You don't want to use recursion? Okay, you don't have to. Let's put in our constructors, let's give options for whether we use zeros or not. And that's kind of the idea of all that stuff there. Now, before we're going to get to the code in a minute. I know you just can't wait to see it, but when I go here to the driver code, this is the summary driver code. And so I would point out to the students, okay, it's in the driver code. I usually will call my class something driver or maybe use a runner. And then there's the main event. I like to mark where things begin and end. That's kind of a habit I've gotten into because it's killed me when I do Python and we don't have ending things anymore. I like to show where things end, even if they don't smart enough to use curly braces to end Python. Sorry, going on a rant for Python, sorry. But I've highlighted the first 3 things that kind of give me an idea what I need to do. So I've inherited, pardon the pun, I've inherited some driver code. I know it works. First thing I see is I created a stage string of 0, and I'm saying multiplicative digital root stage 0. I like to put a heading on this for this reason. It just makes me feel good when I run something, I get something in the console that tells me it's working. Okay, nothing's worse than a blank console to me. So I put a little heading there. Also, the reason I do that is that when I have a header in there and I print out multiple runs, kids can see in the sample code, okay, there's a run, here's another run, here's another run. And so that way they can kind of see, oh, he ran this thing 5 times and these are the results we got. So I'm seeing here, this first thing is I'm creating an MDR object called M1 is a new MDR, and I've given the arbitrary number of 6788. So this is where our show begins. And let's come over. I'm going to go now to the driver code. So I'm in the start code here. Now in the start code, this is a place where you could come in and actually code along with me. And I'm not going to code all of this because I want to kind of take kind of a larger perspective on this. But if you're nervous by the fact that I'm going to leave you hanging and you're not going to know what's going on, in the thing that they gave us in the chat, there is a link there to the final stuff too. So everything, it works. And so let's go through and maybe do that first couple of, if you see here, we got that thing in red. Let's maybe look at the constructor that does that. And then we may go and fill in the gaps by just kind of looking at the large view with final. So here we go. So I go in and I'm looking at this, Now, by the way, there's my sentence. Perhaps clown nonsense is constructive only toward getting settlers underwear. Again, P stands for all classes are public. Clown means we need to have the class keyword. N needs, we need a name for our class. So public class name, that's the PCN. I, what's coming next? All of my attributes. Now, I could come in here and probably should have said attributes, instance variables, IVARs. You might see all sorts of different things they're called. Sometimes they're called field variables. Sometimes they're called properties. And I like to use a lot of those different interchangeable names. But so there's the thing, there's the attributes that we saw. No surprises. I put comments there saying what they are. And then we see that we've got a constructor that's a non-parameter constructor. But if I go back and I look and see what I called first, I didn't call that one first. I called this other one. And so it's the idea of parameter matching. I've got the constructor. It's the same name as the class. It's public. This is the one I want to start with. Why? Because I studied the driver code. And I also know that my loving teacher gave me my example work in the driver code. Here's where, again, this is the driver code. And then notice my students know if they're looking for what they should get, they look in the driver code area and they see the comment blocks. And so there's my little comment, stage 0. And then notice that's the little number, the N0, it goes all the way down to 0. Oh my gosh, we saw a 0, didn't we? And I can see this is what I should get if I'm successfully running this code. So I need to, looking at the clues, there's my title, there's my output. It came from, I created something with a one parameter constructor, and the first rattle of the box is system.out.println M1. Okay, that's what I need to do. So I'm going to go over to the start code. I'm in MDR, the class. There is my one parameter constructor. I got a little comment there to do. And so let's come in and kind of talk through this. I'm just turning to my notes. Let's talk through this one a little bit and then go from there. So I see that it's got one parameter. So I know that the first IVAR that I need to really represent is N0, and I'm going to say N0 is equal to N semicolon. All right. So that's kind of the star of the show. And I see that I've got 1, 2, 3, 4, 5, 6 attributes. A good constructor gives meaning to all those attributes. I try to help them understand that. So I've got, not surprising, N0 is going to be set is N. And then I'm going to say, because I looked at my output, my loving teacher told me that in the driver code, oh, look at it, the MDR was 0. So that means that the attribute should use zeros has to be true, because that's what's indicative. That's what's indicated by the sample output. That's how I would know that. So I go back over, oops, wrong one, sorry. Go back over to MDR. And so I'm just going to go, let's see what I've got here. I've got should use zeros. Equal true. Okay. And so I knew that from the output. The next thing I'm going to say trail, which is one of my attributes, is, now, as you know, I've got to declare the array list. So new array list of longs. And now it's not going to be filled up with anything yet. So I'm just going to go ahead and declare it. That's setting aside the location for it, the memory address for it, so to speak. We'll be adding it to it in a moment. So notice 3 attributes down, only a handful more to go. So that's my trail. The next thing I need is, I'm thinking, well, I don't know what goes in the trail, but I do know the first thing that goes in the trail. What's going to go in the trail first off? When I go back and I look at my output here, when I look at that little example, who goes in the first slot? N0. He's the first entry in the array list, isn't he? So how about I go ahead and do that? I've declared that the trail exists. So I could say trail dot. Now this is a great way to remind the students, okay, we're adding something to a data type. or data structure. It's not a primitive array. How do we put something in there, children? What do we say? Oh, it's dot add. And who do we want to add? N0. So that's going to put it in there. Now, I'm a firm believer in what I call code vandalism. And code vandalism is the idea where I will deliberately break something to watch the computer squawk at me. And so the question might be, what would happen if I forgot to declare the array list of longs and I tried to say trail.add0? And I would actually look at the output and see what happens to remind myself of what the error message might be. But we're not going to vandalize any computers today. Sorry. Now, the real player now is going to be dr for digital root equal, and it's compute digital root parentheses N0. And then I'll talk about that in a moment. I'm going to say did use recursion equal to false. Now, again, you might be wondering, how did you know that you weren't doing that? Well, my output. My teacher gave me driver code I can trust. My teacher gave me output. I look at the summary and I say, oh, my teacher has N0 of 6788. Should use zeros is true. Digital root product was 0. There's my trail. There's a persistence of 6. And did use recursion false. So I'm just following the formula that my teacher told me to use. Now, you might wonder, all right, so there was 1, 2, 3, 4, 5, 6 attributes, 1, 2, 3, 4, 5, 6 things that the constructor did. That's a good sign. Now, the question is, will this silly thing work? Well, it will work if compute digital root exists. So I'm scrolling down here, thinking about my little silly sentence, perhaps kind of nonsense is constructive only toward getting settlers underwear. Now, the U for underwear, I call utility methods. So sometimes I have methods that do things behind the scenes for my class. And so in my way of thinking, compute digital root is a utility method that's doing the work to provide for me the attribute dr, digital root. So I come down here, oh, there's my attributes, there's my constructors, there's my setters, oh, there's my overridden methods, and there's the ToString method, which let me just say quickly what's going on with this. My ToString method, I nearly always have them like a mantra. I tell them, hey, ToString method returns a string. You do not do system.out.print lines here, although they do it all the time. Even in May, they do it. So it makes me embarrassed. But so I said, let's create a temporary string, and then we're going to return temp, and then we fill in the juicy goodness with, in this case, a loop. So I'm saying, well, we want to print out the trail critters, but we don't want to go to the very last one. So I said, trail not size, reminding them it's not length, it's size, -1. And you might wonder, well, why are you not going to the last one? Is that not important to you? But if you go back and you look at the output, if you remember, the output got these creepy little arrows in there. And sometimes I do this deliberately to see if they know to stop the process early. So I've got this leads to this, leads to this. And notice this is the end of the road. And I don't want to print out that arrow on the back end because that's kind of awkward. So that's why I'm not going all the way to the end. There's notice I'm getting my trail value. Now, this is the other thing that I liked about this project is that I'm returning a string, but these are all digits. And so I've got a bunch of digits, but I'm also throwing in kind of a little arrow symbol. So what I've got to do is I've got to take a method called value of and get the value of that thing, basically kind of stringizing it. We kind of do that in Python also. And I'm using the string class with a method called value of that says, hey, you give me a numeric kind of thing, I'll stringize it for you and add it on to temp, which started out as an empty string. And so then I'm going to glue on an arrow. I'm going to concatenate an arrow on, and then look what happens. At the very end, when I pop out of the loop, I will go on to the next to the last one. That's when I tack on the string value of dr, which is the digital root that I've presumably already got because I constructed it in the constructor. So that's kind of a peek at the ToString method. Now, also, while I've got you here, notice that was my so-called overridden method. Now, there's my utility methods. Perhaps clown nonsense is constructive only toward getting settlers underwear. I use lots of utility methods, one of which is my little utility that I'm calling summarize. Now, notice the difference between ToString and summarize. Summarize is void. It's actually doing work of printing out stuff. And so I've got a new line and just basically telling me all the attributes themselves. Don't have to do this, but I just like to know what I had as I constructed it. Now, the real killer now is, having talked about that, is compute digital root. So now I provided that in this case because there's some weirdness associated with it. And I told the students, study carefully, which means, oh, that's too difficult for us to understand, move on. But no, let's study it carefully. So notice I'm receiving along, it's a number, and I'm dealing with stringy kinds of things because I got to know how long that number is. Now, there are many ways of doing this. This is how I thought to do it. I thought, okay, let's stringize it by using the string.value of and get the stringized version of it. So I tell the kids, if it looks like a 77 that we could do a number with, but I'm going to make it a quote 77 so I can count how many digits or how many symbols are making it up. So I call that usually in str for in string. Now I can get its length, and I'm quick to say it's a length method in the string class. So it is hopefully reviewing that. And I know the string length. Now I think, what am I going to do? Well, as long as or while the string length is bigger than 1, I'm going to keep this process going. So that's the overall outside loop. While the string length is larger than 1, what are we going to do? We're going to get a product. Well, I'm going to start with a long called prod because I have no idea how big this is going to be. So I'm going to make sure it's 64-bit. If we can't live with that, we're in trouble. Long prod equal 1, and then a nested loop. A for loop within a while loop. Ooh, isn't that so cool? What are we going to do? We're going to go from starting with 0 up to the string length. We're going to get each and every digit. Now, here's where we could have done it multiple ways. What I thought to do was this. I thought, you may know, and I'm aware that a lot of people don't deal with characters on the AP, but I just think it's irresponsible for kids not to see character as a data type. But so I'm going to grab the character at I. So it's going to get the first character and then the next character, which in my mind, those are digits. But the problem is, again, those dratted data types. We were numbers, now we're strings, and the car add is going to give me a character. Well, a character is not a number. So you may remember that we could cast a character as an integer. And that gives, for old people like me, that's like the ASCII code. If you're more hip, you say it's like a Unicode. It's the code number affiliated with all symbols in mankind have a code number with them. Now we call it Unicode. And it so happens, if you do a little bit of work, you'll find that the Unicode for the number 0 or character 0 is 48. And the Unicode for 1 is 49, and so on and so forth. So if I grab the character like a quote 7 or a single quote 7, and I get the Unicode of it, if I subtract 48, that will give me the actual digit value. So now I'm back to integers. I'm back to digits. So I called it digit. Now look what I'm doing now. I can do mathy things. I can say, hey, if you should use zeros, then product will be times equal digit. So you want to use zeros, knock yourself out. Else, if the digit's not equal to 0, then multiply the product. So this is where I'm excluding the 0, yes or no, using an attribute of my class. Now, once I've gone through that for loop, I've got a nice little product. I've used all my digits in my string. And so then I can add that product to my trail, the add method. Oh, but wait, we got to go back to strings, right? Because we said, let's keep doing this as long as the string's got a length larger than 1. So I've got product, but I've got to re-perceive it, not as like a 49. Oh, wait, it would be no numbers. It's 49. I've got to make it into a quote 49. So string.value of prod makes it back to in string, which is now a quote 49. And then I can get its length. And that's what reinvigorates the while condition that says, hey, did you reach 1 yet? Oh, I guess you're not done then. And we're going to keep on going. So then I've got, when I pop out, then finally, if I've gotten out, that means that the length of my string was 1, it's my digital root product. And I'm going to parse that. Now, this is another weird thing. When I popped out, I had in string as a, like maybe a quote. If you think about our example, it was a quote 8, or in the example from the slide. I need to make it not a quote 8, but a real 8. So I'm going to use this idea of parsing to parse the string from the long class and get back a digital root. Now I had to use long because DR is a long. Actually, it's really overkill. We could probably make it a byte or something because it's really small. It's only 1 digit, but we'll worry about that another time. So there's my digital root. So, and this is where, this is actually a little bit of a mistake. I hope you're going to give me grace on this. The whole point of the stinking compute digital root was to return the DR. Well, what am I doing? I'm going ahead and letting the cat out of the bag and declaring DR right there. So actually, I didn't realize that until about 30 minutes ago. You know, how embarrassing. So even if I comment it out, it won't matter because that's what I'm returning. I'm returning this parsed value of in string, and notice that's what the constructor did. So my constructor, bless its little heart, is using a utility method, compute digital root, taking a long value, getting DR, and now I've got a DR in my hot little hand, and it's a long, it's not in quotes, it's a long. And so I'm done. I got a construction now. Now, the question is, if you can see, if I ran here, it was griping here, but now that I've got this, I'm curious if I save and run at this point, it may crash because I haven't commented out some of the other stuff. Well, notice it worked okay for a while, and then it's crashing again. Well, why is it crashing? It's crashing because I haven't included all of the other constructors. Now, I don't want to bore you walking through all those. Notice I have a constructor that says, hey, you want a long, or I need a long, you want to use recursion, yes or no? I need a long, you want to use zeros, yes or no? You want to use recursion, yes or no? So I've got some things that I can craft how I do my work. But what I want to jump to, we talked about the ToString, we talked about summarize, we talked about compute digital root. Notice the compute digital root recursively is one of the last things to do. So what I want to do is I want to talk you through that and kind of look at it from a bigger point of view. So that's why we're so lucky that we have the final code. So let's warp over to the final code. And hopefully, fingers crossed, if I save and run, I don't have any horrible things happen. So please work. Please work. Oh, there we go. No crashing. In fact, Lori, I learned my lesson here. I need to make that console a little larger, I think. Didn't we?
Oh, we did talk about that. I'm glad you thought of that. Yeah.
Let's see. Is that under console? That's under output, right?
Yep. Console font size. Perfect.
So make it a little larger. Now you've got the output, but so Lori, I do remember things sometimes. So if I look at my output, let's go back and look at the driver code. So we addressed this first couple of things as we showed in our slide. In our slide, we said, well, hey, minimally, we want to get these things working, which we now did. Now let's talk about, next we encountered a should set use zeros. And now this is something I do want to bring up before we talk about the recursion, because I think this is a super big deal. I'm going to go to my final and I look at the driver code and I'm using a should set use zeros to false. Now notice earlier, I had an output where should use zeros was true and I got a multiplicative root, a digital root product of 0. Now, this is a real big deal. And I have a way of telling my students, don't laugh at me. I have a way of telling my students, this is a big deal. And we have a whole discussion at this at the beginning of the year. Brownie points to you if you know who Will Robinson is, okay? And even more brownie points to you if you know what danger Will Robinson means, all right? If you don't, then after the session, go to Netflix and watch the reboot of Lost in Space, okay? And you will know what danger Will Robinson means. Danger Will Robinson is my little catchphrase that says, hey, you're in real danger here, Will, and something's going to eat you if you're not paying attention. So why is this a danger Will Robinson moment? Here's why. If I go back to the setters, now look at my sentence. Oh, I don't have it there. Oh, that's horrible. What is it? Perhaps clown nonsense is constructive only toward getting settlers' underwear. But if I look at the setters are dangerous. Here's why. Is that the moment I start messing with the setter, I'm changing a property of an object. But that can be like a set of dominoes that you dump one and there's things that start happening that you didn't intend. So notice when I did a digital root product for 6788 that did have a 0 in its trail, this is why we like to see the trails, I got a 0. Now, if I come in later and I say, hey, Mr. Driver Code set should use zeros to false, what do I have to do? I have to recompute the trail. I call these side effects. Danger Will Robinson is that if I don't reset the trail, I get something that's inconsistent. I changed one property, not realizing that that property influenced other things. I hope this makes sense to you. And so I will use the little catchphrase DWR. I don't always type out Danger Will Robinson, but DWR, they all know what that means. They all think it's corny. They all think I've lost my mind, but okay, get over it. Changing should use zeros will change other attributes. And so I'm going to change that property to the status that I sent. Oh, I'm going to restart the trail. I'm going to add in 0 to the trail, and then I'm going to recompute digital root. Now, here's why I like utilities. Let's suppose I made my poor little constructor do all that work. I'm going to have to copy that code and put it back in here too. And what if I find later that there's a better way of doing it? Now I've got to replicate that in 2 places. We love underwear, right? Perhaps clown nonsense is constructive only toward getting settlers' underwear. Okay, so we love the utility methods. So there's my utility method for computing digital root. I'm using it again, and I have no side effects. So what's the proof that I have no side effects? I have no side effects because when I ran it again without using zeros, my digital root product is no longer 0. It's what? It's a 2. Why? Because I said, don't include the zeros. All right. So I really like to show them, hey, whenever I say we're going to make a setter, in my perfect world, all the students would get up and shout, Danger Will Robinson. Okay. They don't. But, oh well. So there's my digital root product. Okay. So now let's look at the driver code. What's next? In the driver code, we had said we want to use this and we print it out. It's another reason I like to summarize. I can see all the properties all in one place. Now, these are other constructors that I'm just adding extra abilities to tweak the properties, and that shouldn't be any big surprise to us. Let's talk about the idea of recursion though, okay? Because that's difficult for us if we admit it to everybody, and it's difficult for students too. Let's go in and see if the recursion stuff makes any sense. So I'm going to come down. Oh, no, now, by the way, I have a little setters block. Danger Will Robinson. Now think, did set did use recursion, and I can turn that off. Oh, I would made a little note. Not a Danger Will Robinson moment, because whether or not I use recursion doesn't change any properties. Here's how you know whether you've got a Danger Will Robinson moment. Does one property influence others? In this case, it did. In this case, it didn't. But I like to bring that out to the students. Okay, so the last thing here is the compute digital root recursively. Now, recursion, I just find it difficult. I don't know about you, but I just find it difficult. So I usually will write something iteratively first to make sure I can just get it to work. And then I will extract the ideas from this, hopefully, and it will make the recursive stuff a little bit less difficult. Now, looking at it from a kind of like a 50,000 foot viewpoint, I noticed that compute digital root has got a nested loop. It's got a while and a for, right? Or a for embedded in a while. Now, if you look at this from the big picture perspective, I'm going to bring this up my screen so you can see it maybe a little bit better. Compute digital root recursively. Oh, I see a for loop. What's missing? The while loop. Because I remember that recursion is a way in which we can get repetition without using a typical loop. I did need this inner loop, but let's go through and see if this makes any sense. I'm receiving an in, a long. I'm going to compute it recursively. Well, earlier I stringized it. I declared the use of a product, and then I got the length of my string. Now here's, if you teach recursion, you remember we must have a base case. Otherwise we have a runaway train and people die. So we have to have an if else block. The if else, I usually like to write the if block as the base case. Y'all don't have to do that, but that's what I do. And I'm saying, hey, if your string length is 1, end of the road, persistence is the trail size minus 1, because presumably we've already got our trail size. We subtract 1, that's the persistence. And we're going to return the parsed long from in string using the long class's parse long method. That's the base case. In fact, maybe I should remind myself base case. Okay. So in other words, if I give you a single number, that's just boring. It never went through anything. All right. But where there's an if, there's an else, and that's, I mark as the end of my recursive call area. This is where the weirdness happens, right? So I've got to, just like I did in the iterative version, I'm going to set prod equal to 1. Notice I pre-declared it up here so that everybody knows who prod is. I said prod is 1, and then there's my for loop, much like I did before. So nothing really has changed. Notice I do my prod work. I'm multiplying, extracting digits. I'm adding that to the trail. Now here's the part that's different. The while loop is missing, isn't it? Why? Because it's the recursion that's doing the work of the while block. So here I'm saying return what? Compute digital root recursively of prod. Now here's how I'm thinking about it. Let's think about our earlier example of 77, which was easy to do. 77 is not a single digit critter. It's 2 digits long. So it's going to go through the process, and I'm going to get a product, in that case, of 49. And yes, I can do this arithmetic. Now, 49 is going to be the new prod. So I gave it a 77, but now it's put on the stack, so to speak, is going to be compute digital root of 49. So it's going to go through the razzmatazz with 49, and then, oh, 36 and so forth. And so eventually it will pop out and get the thing. I think we had what, an 8 early or something from the little example. So I don't think I could have written this, frankly, if I hadn't done the iterative part first. But having done the iterative part first, and I see the complexity of it, and I see, oh, it's a nested while or nested loop with a while and a for. Oh, okay. It makes sense that at least one of those loops would go away. This is iterating through the string, but it's the recursion that's going through and reprocessing those values within the trail. And so there we see then, there's our recursion. There's the other one. Let's see, what have we not mentioned here? I think we kind of at least a highlight of all this. Now, if you wanted to try your hand at this, of course, you've got the start code. and you could go in and you could either be a meanie and give it to your students and see if they can do it for you, or you could try to do it yourself, but you've got the solution as well. And I see we've got about 5 minutes left, but I don't know. I was asking my team to see if there are any questions. I didn't see any, but are there any people with desperate questions?
Laura had dropped something into chat if you'd like to check that out.
Oh.
Other than that, I don't see questions in chat, but if you've got questions, definitely toss those in. And also, we are a small group. So if you do have a question, feel free to unmute as well.
Yeah, she's added to it. This is great. And I just used a sentence again as a way. I have them memorize this at the beginning of the year. They don't even know what it means. They just know that he's lost his mind. Mom, can I drop this class? And but eventually we start to say, what does the P mean? What does the C mean? What does the N mean? And so on and so forth. But if I find if they have to write something from scratch, this is actually a good order too. I've got to, of course, I've got to get the PCN stuff first, followed by attributes, constructors, and then I nearly always get the overloaded ToString method. Now, there's another overloaded method that I didn't use here. Anybody know what it is? What's an overloaded method? We should always provide. Okay, good old equals method, right? The object class provides an equals method, but we would like to know whether objects are truly equal. And here's a rabbit we could chase. Is that what if we said that a digital root, that MDR was the same, not if its initial value was the same, but maybe two digital root products are the same if their ending values are the same. Because that way we could search for initial values that have the same digital root product. Hey, how many numbers are there between 1 and 1,000 that have a multiplicative digital root of 8? We could use an equals method to help us find that. So that's just one thing that just flies off the top of my head that I hadn't even thought of, but that's how fun this stuff is.
Does anybody have any questions? I do have to say that being here at your workshops, Kent, makes me wish I could be in your class. So I get very into what you're doing. Oh, and Laura mentioned, Kent, you're a programming superhero. Love your catchphrases. So much good stuff in such a short period of time.
Thank you, Laura. I appreciate that. Don't be sure to watch Netflix Lost in Space. You're in for a treat if you haven't seen it.
This was awesome, Kent. And we did have another workshop from Kent earlier. How many have we done? We've done a few, haven't we?
2 or 3, I think.
Okay. So yeah, Kent has got some other ones out there, and I've already told him that, whatever he wants to do this summer, he's good. So definitely keep an eye on that free PD page, everybody, codehs.com/free PD for more. And Linda already tossed it out there. So it's that fast. And I'll make sure that's in the follow-up email as well. We have one more request for everybody. If you could take just a moment to fill out our workshop survey, that would be awesome. To get to that, Linda's got that link in chat as well, codehs.com/workshop survey. Take a moment to fill that out. Let us know how we did and what else you'd like to see. We would love to hear your thoughts on what else you would love to have us do, have Kent do, and all of that. I'll also list a few other links. We'll have things like, and Linda, you don't have to toss all these in. This is just kind of off the top of my head. So I'm catching her off guard. If you are not a certified educator, make sure to check into the CodeHS Certified Educator Program. I'll make sure to include that link as well. We are also looking for more passionate teachers, passionate CodeHS teachers to join Kent in the teacher trainer program. We have cohort 2022, and you've got until May 12th to submit your application. So I'll make sure you get that link as well.
It's well worth it.
Oh, thank you, Kent. It's an amazing program. I absolutely love the teachers we have in this program, and I'm looking for that next cohort. So I see a lot of names that I recognize. So, go ahead and think about applying for that. We'd love to have you as part of the program. So, but yeah, Kent, this was amazing. Thank you so much for delivering an amazing session. We'll be getting some more of Kent's sessions out there very soon. So keep an eye on that free PD page. If you are curious about P5JS, we do have a workshop coming up on Thursday. So just 2 days from now. And I think it is an hour earlier. I'll double check that time. And that is with another one of our teacher trainers, Chip Kramlich. And he will be delivering a session on physics, animation, and P5JS. If you're not a physics teacher, do not let that scare you. It's animation and P5JS. I have to say that's one of my newest obsessions. I absolutely love P5JS. I'd highly suggest that you check it out. It's going to be a great session as well. So again, Kent, you are amazing. Thank you so much. And thank you to all of you for spending time with us today. You've got a lot of things you could be doing right now, and you chose to spend it with us. Thank you, thank you, thank you. We hope to see you at another workshop soon. Thanks, everybody. Have a great night.